Hello there, this is Mrs. Ortiz, and we are going to cover Objective 2 for Unit 2. Unit 2 is functions, and Objective 2 is domain and range. So in the previous video, you heard Mrs. Keys tell us that domain is the set of all possible input values, and range is the set of all possible output values. And so if you just take a minute and think about what that might mean and the different ways that that could look, and go ahead and pause and answer the essential question now. Okay, so after you've written down what you can remember or what you can maybe predict about domain and range of a function for the essential question, what is it? Domain is the set of all possible input values, and another way of saying input values is x values. So we're going to say x values here. Okay, and remember from yesterday, other ways that we talked about that were input values, independent variables, and that is the domain. Okay, so the range is is the set of all possible y values for a function. All right, and remember that that can also be called the dependent variables and the output. All right. So when we think about this, we can really think about domain and range kind of being two different types of sets of numbers. So the first one is called set notation. Okay, so we're looking here and we're talking about set notation. And set notation is used when you're listing a finite set of values. So finite means you know exactly how many numbers are in the list. So it says here in our notes, we use these brackets. Okay, so these brackets right here and commas to list out our set. And it says in our notes to see examples A, B, C, and D below. So if we look at these examples, we can see that we have a finite set, right? We've got 3 sets of points here and 3 sets of points here, and we've got 3 sets of points here, and we've got 3 sets of points here. Okay, so maybe you have 7 points, but you have a finite set. You can say exactly how many points there are in your set. All right, and that's different than when we use interval notation, because interval notation is when we are listing an infinite set of values. So when we're talking about an infinite set of values, we're maybe looking at a graph like E and F. Okay, and the reason is that these are infinite is because there are an infinite number of points that could lie on that line. Okay, so that's the difference between set notation and interval notation and when you would use them in different situations. Okay, so we'll go back up here and talk about interval notation in just a minute, but let's take a look at these examples in this table down here for set notation. So we are going to write the domain and the range for A, B, C, and D in this table. Okay, so I'm going to zoom in here. Hopefully we can still see A. And for domain, when we talk about either set or interval notation, okay, first of all, we can say that the domain is this D with this double bar, and then we're going to give a colon, and then we're going to open our set. Okay, so the domain is just all of the x values. So in A, it's in a table format, and we just want to list the x values from smallest to largest. So our x values are -1, 0, and 1. And that's it. That's our domain because this is a finite set. We know exactly what numbers are in our domain from our table. Okay, and similarly, our range, so in R with a double bar, is just going to be the list of y values. And so we're going to open up our bracket and we want to go from smallest to largest. So our smallest number would be 0, and then our largest number would be 1. And even though 1 is repeated in here, this is still a function. and we don't need to write it more than once in the range. We just need to list the possible values that y could be. So there's no need for repeating it, okay? So let's take a look at table B. The domain is the set of the x values. So we've got 0 and 3 from smallest to largest. And the range is the set of y values. So the smallest value there is -6, 1, and 6. Okay. You can go ahead and try C and D, and I am going to pause and insert the answers, and then you can check your work here. Okay, so hopefully for C, you got that the domain was the set of 2, 3, and 4, and the range was a set including -1 and 3. For D, the domain was the set 0 and 1, and the range was the set -3, -2, 8. Now, you can have domain and range for relations and functions. So remember from yesterday that D was not a function, C was a function, and A was a function, but B was not a function, okay? So, and then if we look at these graphs, remember that E was a function and F was not a function, okay? But that doesn't change whether or not you can have a domain or range. You can have a domain or range for relations and functions. Okay, so interval notation is important when our graphs are continuous. So interval notation lets us get all of these points. Remember, there's an infinite number of points on any kind of line or continuous graph. So if we go back up here and take a look at our interval notation information, it says that it is used when we are listing infinite sets, an infinite set of values. Okay, and the notation looks a little bit different. This time we're using parentheses and brackets, and there are instructions on when you use each. Okay, so if a value is not included in the domain or range, meaning there's a hole in the graph, you're headed towards infinity, we say that we can't ever quite get to infinity, so we can't include it. We use this bracket, okay? If the value is included at the end of the graph, then we use this kind of bracket. Okay, sorry, I misspoke a second ago. We're talking about parentheses when the value is not included. Okay, remember that domain values are written from left to right along the x-axis, okay, and they are separated with a comma. And range intervals are written from bottom to top along the y-axis. And again, those two values, the low and the high values, are separated by a comma as well. Okay, so we're going to look at these graphs for E and F and determine what their what their values are when the graph goes absolutely all the way to the left, to the right, how low it goes, and how high it goes. So if we look at E, the domain, remember, is our x values. So our x values are our left to right values. So we're looking at the x-axis, and we want to know how far does this graph go? All right, how far left and how far right does this graph go? Well, because it has arrows on it, we know that it continues on, right? So if this graph continues and continues and continues and continues, it's going to continue on forever. So this graph is going to stretch all the way out left to -infinity. And then if you look at the right side of it, okay, we follow it this way, it's going to keep going right and right and right and right, and it's going to stretch all the way out to a positive infinity. So by looking at the x-axis and how far a graph can stretch left and right, we know that the domain goes from -infinity to positive infinity. Okay, now there's your interval notation with the parentheses, and because we can't ever quite get to infinity, we use the parentheses to show that it's not included. Now for the range, we want to know what is the lowest possible y value for this graph and what's the highest possible y value. So for our range, we're going to look at the y-axis and the possible values there. So if we look at this graph, our lowest value here is right here at -1. That's as low as this graph will go. So it stops at -1. And if we look at our graph on both sides, it continues to go up and up and up. And just like left and right, it's headed towards a positive infinity. So its low value is -1, and the graph actually goes through -1, so we need to use this a bracket, okay? And its high value is infinity because it's headed towards infinity. But again, we can't reach infinity, so we use a parenthesis. Okay, let's take a look at f. So for our domain, we are looking for the smallest value to the left and right. So we are looking on the x-axis. This graph stops at -2, right here, right? So our domain stops at -2, that's as low as it goes, and it continues on and on and on and on. So it goes towards a positive infinity. And remember that this is a relation, not a function. So our domain goes as low as -2, and it's included, and it goes as high as infinity, and we can't quite get there. For the range values, we were looking for how low can it possibly go. So this continues to go on and on and on and get lower and lower and lower. So it's going to head towards negative infinity. No, -8, negative infinity. And for this side of the graph, it's going to continue to go up and to the right, and it's headed upwards towards a positive infinity. So our range is going to go from negative infinity to positive infinity. Okay. All right. So we have a couple more examples that we're going to take a look at here. And the directions say to write the domain and range in interval notation from the given graphs. So let's take a look at this first graph. So our domain, how far left does this graph go? This arrow continues to go, it extends on, right, left, as far left as possible, which is to negative infinity. And then the arrow continues on the right side to grow to a positive infinity. Okay, for the range, what's the lowest possible value here? Well, it continues to go down and down and down. So it's from negative infinity, and then it's going to continue to go stretch up and up and up, so towards a positive infinity. For this second example, our domain, if we're looking for the possible x values, all of the x values line up on this same line. So the only x value that we have is 4. Okay, every point has an x value of 4, which means we have to include 4, so we're going to use a bracket, and that's the only number we're going to include. For the range, our lowest value, it looks like we have this open circle at -6. Okay, now because that circle is open, just like on an inequality, that means that number is not being included. So it goes up to -6, but it's not included, so we're going to use a parenthesis. And then this line shoots up towards infinity. And again, we can't get to infinity, so we're going to use a parenthesis. For this third example, for our domain, if we look at our arrows here, our arrows extend and our graph continues to go left and left and left, and it's going to head all the way towards negative infinity. It's going to be slow and really tall, but it's going to head towards infinity. And the right side is going to reach towards a positive infinity. So our domain is negative infinity to positive infinity. And then our range has a low value. Its lowest possible value is -1, and it is on the graph, so it's included. And our highest possible value, well, it's going to keep reaching up, is a positive infinity. Okay, in our last example here, we have a domain. We want to know how far left this goes. This graph stops at -2, and that circle is closed, so it is included. So our domain is it begins at -2 and it continues. So we've got an arrow again. So it continues to go right and right and right, and it's headed towards infinity. And our range, okay, our lowest possible value, well, this graph is going to continue to go downward, right? So we're headed towards -infinity, but it stops right here at 2. So it begins at -infinity, but stops at 2, and that 2 is included because it was a closed circle. Okay, so how is it that we identify the domain and range of a function? We identify the domain and range of a function by looking at all of the possible x values and y values. Okay, so the domain includes all possible x values and the range includes all possible y values. Okay, and then remember that it can be written as domain and range. So there's the symbols for it, the notation can be written in set notation or interval notation, and that is dependent on what the context of the problem is. So set notation is for a finite number of points where you know exactly what the numbers are, and then interval notation is used for infinite relations. Okay, and lastly, for today's reflection on your learning, I would like you to think about a question that you would have about domain and range, and jot your question down. And if you don't have any questions about domain and range, then you can write your own math question and answer it about domain and range. So something you might expect to see on a homework assignment or a test. Okay, have a great day. Bye.